Okay, class, so we've been discussing how to do our rotations around a circle using positions. Well, we talk about those using degrees so far because it's something very familiar to us. Ever since we were little, we would pull 360 on our roller skates, you're just turning a full circle. Doing a 180 is just turning around. Well, there's another way to measure angles, and this is the first time that we've been introduced to this, but we measure an angle with something called a radian. And if you've forgotten from class, a radian is a measurement. If we do this, we take the radius of our circle, that length of the radius, and you place that radius along the outside edge of the circle, this little angle that's cut out here is referred to as 1 radian. And as we studied that, and as you think about maybe circumference of a circle, there's this whole idea that circumference is 2 pi times the radius. Well, that means that that radius can fit around the circle 2 pi times. So I could take this radius and put it there and there and keep going until I had exactly 6.28 and so on radii around the circle. Well, that wedge that's cut out, that 1 radian wedge, I could then fit in 6.28 of those wedges. So there's also 6.28 radian measures. So in a full circle, I would see 2 pi radians. What that allows us to do then is to say that 2 pi radians is equivalent to 360 degrees. I'm going to relate that to linear measurement for a moment. When you start measuring an inch, it's standard, US standard to measure an inch. But the metric system says that an inch is about 2.54 centimeters. Both of those are measures of length. Both of those allow you to see how far you've gone using a standard measurement linearly. This, however, is an angle measurement that also means the same thing. Going a certain angle measure in radians and going an equivalent angle measure in degrees could be calculated using this ratio, 2 pi radians for every 360 degrees. Now, typically, in our math classes, we reduce this a little bit. We write the ratio instead of radians to degrees. And when you write the ratio, that's 2 pi over 360. But we learned early on that in fractions, we like to reduce these. So this becomes 2 into 360 goes into 180 times. It becomes pi over 180. So we oftentimes see pi over 180 or 180 over pi, depending on how we want to write the ratio. Degrees to radians would then be written as 180 over pi. That becomes the ratio that we use to do our conversions, to figure out how many radians are in degree measures of degrees into radians. But I also want to think in terms of the portion of the circle we're on. So before we get into just straight out conversions, let's go ahead and imagine what pi looks like on a circle. So I'm going to take this radian measure off, okay? And if I think about going around half of the circle, this will be a rotation of 180 degrees. We are also at half of a revolution, okay? Half of a revolution, revolution being all the way around the circle, half the revolution means I'm at half of 360 degrees, which is where the 180 degrees comes from. But I also could say that I'm at halfway around a circle, I'm half of 2 pi radians, which is equivalent to 2 pi over 2, or pi radians. So in half of a circle, we have pi radians. There are certain values around the circle that we use quite frequently. And so what I'm going to do now is break my circle into smaller pieces. I'm going to focus on this quadrant for a moment. If I break this quadrant into 2 equal pieces, this is like taking the 90 degrees of the quadrant and breaking this piece into a 45-degree angle, this into a 45-degree angle. And if I kept going, I could split up this quadrant into 2 equal pieces as well, making this 45 and that 45. If we take a look at just the top half of the circle, I've broken the top half of the circle into 4 equal pieces. In the top half of the circle, I have pi radians. So I'm taking pi radians and breaking those into fourths. And so those fourths become, or this measure becomes, a radian measure of pi over 4. That is equivalent to pi over 4. Then 2 of those would be 2 pi over 4s. This would be 3 pi over 4. And this, of course, would be 4 pi over 4. And if we reduce the fractions, this 2 pi over 4 would simplify to be pi over 2. So 90 degrees is equivalent to pi over 2. 4 pi over 4 is just pi, which was the full 180 degree measure. Okay? So thinking in fourths helps us with the 45-degree angles. And we can keep going around the circle with pi over fourths, and we'll do that more in class to practice. But let's now take this pi, and let's break this into, instead of fourths, let's break this pi, which is half a circle, into sixths. So let's break this quadrant into 3 equal pieces. Okay, so now the 3 equal pieces would have to yield a 30 degrees here, another 30 there, and another 30 there to equal the 90 in the first quadrant. If I kept going with that idea, I would have to have another 30 here, another 30 here. I now have 6 equivalent pieces of pi. Okay, so this piece right here is 1/6 of pi. This is pi over 6. And this here would yield 2 pi over 6s. 3 pi over 6 simplifies to 1/2 pi. 4 pi over 6, 5 pi over 6, 6 pi over 6, thus making pi. What I want to focus on is this one for a minute, 2 pi over 6. You reduce that fraction, it becomes pi over 3. That is a 60-degree mark. So the multiples of the 30 and the 60 and the 45 are used quite frequently in our math classes. You can see that knowing 30 is the same as pi over 6, 45 is the same as pi over 4, and noting that pi over 3 is the same as 60 is going to come in handy very well. It's a wonderful thing. You've got to remember our fractions.